There's a photograph sitting in a Russian archive that very few people have ever actually looked at closely, and the man who finally did spent the rest of his career paying for it. It shows the surface of another planet, a place hot enough to melt lead, where no spacecraft has survived more than a couple of hours since humanity first tried to land there. In that photograph, something appears that was not there minutes earlier. It changes shape, it moves, and then it vanishes completely, as if it had never existed at all. The man who noticed this was not a fringe theorist. He was one of the most respected scientists in Soviet space history. And what happened after he spoke up tells you almost everything about how dangerous it can be to ask an honest question. Nobody wants answered. To understand why this single photograph still matters more than 4 decades later, you first have to understand exactly what Venus actually is, because most people walking around today have a completely wrong picture in their head. Venus sits closer to the Sun than Earth, almost identical in size, and for centuries, astronomers assumed it might be a warmer, wetter cousin of our own planet, maybe even hospitable. That assumption collapsed the moment humanity actually managed to look underneath its clouds. The atmosphere of Venus is overwhelmingly carbon dioxide, and it is so thick that the pressure at the surface is roughly 90 times what you feel standing at sea level on Earth. To find anything comparable on our own planet, you would need to dive nearly a kilometer underwater, down where sunlight stops reaching and the ocean itself becomes a crushing wall. Except on Venus, there is no water providing that crush. It is simply air, pressing down with the weight of an ocean on solid rock. And then there is the heat. The surface of Venus sits at a near constant 460 degrees Celsius, hot enough to melt lead, and it barely fluctuates anywhere on the planet, day or night, equator or pole. Wrapped permanently around all of this is a thick, unbroken layer of cloud, made not of water vapor like the clouds drifting over your head right now, but of sulfuric acid droplets, so dense that from space, in ordinary visible light, you cannot see the surface at all. Venus keeps its face permanently hidden behind a poisonous veil. So here is the problem the Soviet Union decided to solve anyway, against every reasonable expectation of success. To land a working machine on Venus, you have to build something capable of falling through acid clouds, surviving crushing pressure, and keeping delicate electronics alive in heat that destroys almost any material known to engineering, long enough to actually do science and transmit the results home before everything inside simply cooks. Beginning with a probe in 1972, the Soviet space program successfully landed working machines on the surface of Venus 9 separate times. Not flybys, not orbital photographs taken from a safe distance, actual hardware sitting on actual Venusian rock, transmitting data back to Earth before the planet itself destroyed it. And here is something worth sitting with for a moment, because it reframes everything that follows. Those Soviet landings remain to this day the only direct ground-level data humanity has ever gathered from the surface of Venus. Every modern map, every radar model, every scientific paper describing what the surface actually looks like, all of it still traces back to instruments the Soviets dropped through those clouds more than 40 years ago. Nobody has been back to the actual ground since. Which means every photograph those old machines managed to take before dying in the heat carries a strange, disproportionate weight. They are not simply historical curiosities sitting in a dusty archive somewhere. For half a century, they have remained the closest thing humanity has to physically standing on Venus and looking around with our own eyes. The man at the center of this entire story, Leonid Ksanfomalidis, was not some outsider chasing headlines. He graduated from a top Soviet technical university in the mid-1950s, joined the Soviet Union's Space Research Institute in 1968, and eventually rose to lead an entire laboratory studying the light and heat radiating off other planets. His instruments flew on mission after mission, including the Soviet probes sent to Mars. He personally designed sensors that flew on the very Venera landers this story revolves around, instruments called Groza, and those sensors achieved something genuinely historic in their own right. They were the first devices ever to detect intense lightning storms occurring inside the clouds of Venus. Sit with that for a second, because it matters enormously for everything that follows. Long before any of this became controversial, this was a man who had already pointed real instruments at Venus and discovered something real, something independently confirmed, something that fundamentally expanded human understanding of that planet's atmosphere. So when, decades later, this same respected scientist sat down with old photographs and announced he saw something moving in them, the scientific community could not simply dismiss him as a random crank chasing internet fame. He had earned, through decades of legitimate work, the basic right to be taken seriously, even when what he was claiming sounded almost unbelievable. The spacecraft at the heart of this entire controversy was called Venera 13, built alongside an identical twin to take advantage of a planetary launch window in 1981. The two probes left Earth just 5 days apart, and Venera 13 spent roughly 4 months crossing the gulf between the planets before its descent module separated and began falling toward the Venusian surface on the 1st of March, 1982. Think carefully about what that descent actually required. The lander deployed a parachute initially, but Venus's atmosphere is so dense that at a certain altitude, the parachute stopped being the right tool entirely. So engineers had it cut away and let the thick air itself act as a natural brake for the remainder of the fall. The lander touched down at roughly the speed of a brisk fall, landing in a region of bedrock outcrops surrounded by dark, fine-grained soil. And then it did something almost nobody expected, including the engineers who built it. Venera 13 was designed to survive on the surface for approximately 32 minutes before the heat would inevitably destroy it. It survived for at least 127 minutes, more than 4 times longer than anyone had promised. Every single one of those extra minutes was, in a very real sense, a gift the machine was never supposed to receive. The secret to that survival was surprisingly elegant. Engineers had packed the sealed pressure vessel with blocks of a salt-like substance that absorbs enormous amounts of heat as it slowly melts, essentially buying the electronics inside extra time before the Venusian furnace finally won. While it lived, the lander stayed remarkably busy. It drilled into the surface and pulled a sample into a sealed, pressure-controlled chamber for analysis, identifying the rock as a dark volcanic material. It carried microphones that recorded the first sounds ever captured on another planet: the howl of Venusian wind, the thud of its own landing impact, the small explosive pop of its protective lens caps being blown away, and the grinding hum of its own drill. And it carried 2 cameras, mounted to sweep back and forth and build up panoramic images of the alien landscape surrounding it, line by line, scan by scan. For nearly 30 years after those images came home, almost everyone who looked at them looked at exactly one finished picture per landing site. And what almost nobody realized is that this single, clean image was actually a kind of optical illusion. The polished panoramas circulating in textbooks and documentaries were not raw photographs at all. They were composite mosaics, carefully stitched together from the best surviving fragments of several separate scans, each scan having lost some data to transmission noise along the way. That distinction is exactly what set this entire controversy in motion, because Sunfomality realized that nobody had ever bothered to take the individual, uncombined frames and lay them directly side by side to see what changed between one and the next. So that is precisely what he did. And the question he asked himself, almost childishly simple on its surface, turned out to be far more complicated than it first appeared. From one frame to the next, does anything actually change? What he reported finding became the foundation of everything that followed. According to his published analysis, several objects appeared across these sequential frames, ranging in size from roughly 1/10 of a meter up to about 1/2 a meter. Objects he described as having genuinely unusual shapes. But the truly strange part was not simply their appearance. It was that they refused to stay still. They were visible in some frames and completely absent in others, or they appeared to shift their form entirely between one image and the next. He gave them names that would eventually circle the globe. One he called a disk, one he called a black flap, and the one that would generate international headlines he called a scorpion. The scorpion deserves careful attention because it represents the clearest example of exactly what Sunfomality believed he was witnessing. By his own account, the object appeared in frames captured by one of the lander's 2 cameras at around 90 minutes into the mission, well after the machine had already been sitting and operating on the surface for over an hour and a half. That specific timing struck him immediately as significant. His first instinct was the obvious, mundane explanation, that this was simply a piece of the lander's own hardware that had broken loose. But when he checked the technical records, that explanation fell apart. The lander kept functioning normally for a full additional hour after the object appeared. And if a genuine piece of the machine had actually fractured off in that heat, the resulting breach should have caused catastrophic, rapid overheating and failure almost immediately. It did not fail. It kept reporting perfectly healthy operation for another 60 minutes. So Sunfomality went back through the earlier frames at that exact same spot on the ground, and he described what he saw as a slow, methodical sequence. At 7 minutes into the mission, there was a shallow groove in the soil where the violent landing impact had thrown dirt aside. By 20 minutes, the sides of that groove had risen and grown larger. By the 59th minute, part of a regular structured shape had begun emerging inside it. And by the 93rd minute, the full object had, in his own words, completely emerged from underneath a thin layer of soil, he estimated at only a centimeter or 2 deep. The entire process, from the first disturbed groove to the fully visible shape, took roughly an hour and a half. Then, by the 119th minute, it had disappeared from view entirely. Here is where it becomes critically important to be precise about exactly what kind of claim this actually was, because the distinction matters enormously. This was never presented as a confirmed measurement. It was, by Sunfomality's own framing, a proposed hypothesis, his personal interpretation of what he believed the frames were showing him. He suggested that the violent, explosive arrival of the lander, the firing of pyrotechnic bolts, the grinding drill, the impact throwing soil several centimeters deep, might have accidentally buried something living near the landing site. He went further, speculating that whatever this was had limited physical strength, and that the slow hour-and-a-half emergence represented something struggling to dig itself back out from underneath the disturbed soil. That is a genuinely extraordinary claim for any serious, credentialed scientist to put into print. A structured object slowly emerging from beneath the ground on the surface of a planet hot enough to melt lead, and then simply disappearing again. And he added one specific, fateful sentence to his published paper, insisting that absolutely no retouching, drawing, or digital manipulation had been applied to any of the images. That single sentence, more than any other detail in this entire story, is where the real trouble began. Before getting to that trouble, it helps enormously to understand just how difficult it genuinely is to see anything reliable at all in images transmitted from the surface of Venus, because nearly every layer of this entire debate ultimately comes down to one fundamental question. What does it actually take to capture a usable picture under conditions like these? The honest answer is that an enormous amount of imperfect, error-prone engineering stands between the Venusian surface and any image a human being eventually looks at. Start with the lighting itself. Venus is wrapped in that permanent shell of acid cloud, meaning the sunlight that actually reaches ground level is dim, diffuse, and constantly shifting as unseen clouds drift overhead, far above the lander. Comparing two images, taken roughly an hour apart, you can genuinely watch the quality of the light itself change, sometimes sharper, sometimes softer, almost certainly because the cloud cover passing high overhead kept throwing shifting patches of brighter and darker sky onto the ground below. That instability in lighting alone introduces real, unavoidable differences between otherwise identical frames. Then there's the ground itself. A spacecraft does not arrive on a planet's surface gently. Venera 13 struck the surface hard enough to physically disturb the soil, kicking dust and debris both onto its own surfaces and across the surrounding landscape, and some of that loose material then visibly blew away. During the short window, the lander remained functional. Comparing images taken an hour apart shows soil gradually being blown clear of the landing platform itself, meaning the visible scene was genuinely changing, not because anything biological was moving through it, but because the violent act of landing had stirred everything up, and the Venusian wind was slowly settling the chaos back down. And then there's a deeper complication that has absolutely nothing to do with Venus itself and everything to do with the physical process of getting these images back to Earth at all. The lander's images were relayed through an orbiting companion spacecraft using two distinct methods of encoding the signal onto a radio carrier wave, and those two transmission methods produced two genuinely different kinds of noise artifacts in the final processed images. Compare one transmitted panorama against a slightly different version of the supposedly same scene, and you do not get two identical pictures. Its own authors noted plainly that you cannot responsibly decide in advance what specific conditions life might successfully exploit on a planet with an evolutionary history completely unlike our own. Assuming Venus must necessarily be lifeless simply because it is brutally hostile to human biology represents its own subtle form of bias, sometimes called terrestrial chauvinism within the scientific community. The probability, by their own careful accounting, weighed overwhelmingly against the scorpion representing genuine life. But probability, no matter how heavily weighted, is never quite the same thing as absolute certainty. And the honest, complete answer remains exactly this. Almost certainly not, but never say never. If this story ended there, it would amount to little more than a sad historical footnote. A brilliant, accomplished scientist decades past his most important real discoveries, ultimately seeing faces and figures emerging from blurry clouds of noise. But the deeper question Xanthomaladia was genuinely asking never actually disappeared. It simply relocated, shifting upward, off the punishing surface entirely and into the sky above it. In 2020, an international team of astronomers announced something about Venus that had absolutely nothing to do with decades-old Soviet photographs, and everything to do with that exact same underlying question about life on a supposedly impossible world. Using a telescope based in Hawaii, later independently verified, using a far more sensitive array of radio antennas in the high desert of Chile, researchers detected the faint chemical fingerprint of a gas called phosphine drifting somewhere within the thick clouds of Venus. The detected quantity itself was genuinely tiny, roughly 20 molecules out of every billion, an extraordinarily faint whisper buried deep within the data. But the reason that whisper mattered so enormously comes down entirely to what phosphine actually represents on a rocky planet like our own. Phosphine functions as what scientists specifically call a biosignature, a gas strongly associated with biological activity, wherever it appears on a world like Earth, produced either through industrial human activity or by microorganisms living in oxygen-poor environments. Ordinary lifeless chemistry occurring naturally on a rocky planet produces almost none of it under normal circumstances. That is precisely why researchers had already spent years studying phosphine, specifically as exactly the kind of gas worth searching for, as a potential sign of life on planets orbiting distant stars. And suddenly, here it apparently was, on the very next planet over from our own. The research team responsible did the scientifically responsible thing immediately. They systematically investigated every plausible, non-biological pathway capable of generating phosphine on Venus. Sunlight-driven atmospheric chemistry, surface minerals lofted into the air, active volcanism, and the same atmospheric lightning that Xanthomelides' own instruments had first detected decades earlier. They found that all of these known lifeless sources combined would still fall dramatically short of producing the actual quantity being observed, by their estimate, short by a factor of roughly 10,000. So what then could possibly be generating it? Here is where caution becomes absolutely essential. And to their credit, the researchers themselves remained extremely careful throughout. A biosignature detection is never the same thing as discovering an actual living organism. Detecting one suggestive gas does not mean life has been definitively found. It means a genuinely important scientific question has been formally opened. And that question only became more complicated almost immediately, because if life genuinely exists somewhere within the clouds of Venus, it would have to survive in one of the most punishing environments imaginable anywhere in the solar system. The high cloud layers where phosphine was detected sit at a temperature that is almost surprisingly mild and pleasant. But those same clouds are composed of roughly 90% concentrated sulfuric acid. The toughest known microorganisms on Earth can only tolerate a small fraction of that level of acidity before being destroyed. Anything theoretically surviving inside Venusian clouds would have to be fundamentally unlike absolutely anything within current human scientific experience. Skepticism arrived quickly, exactly as rigorous science demands it should. Multiple independent research teams reanalyzed the original observational data. Some argued the detected signal resulted from data processing artifacts, rather than representing a genuinely real chemical signature. Others proposed it might actually be an entirely different molecule masquerading convincingly as phosphine within the data. The original research team even discovered and openly corrected a flaw in their own initial analysis, making the correction fully public specifically, so the broader scientific community could independently test and verify their revised conclusions. What has happened since then, bringing this story fully up to the present moment, matters enormously for understanding where things genuinely stand today. A dedicated long-term observation campaign using a powerful millimeter-wave telescope subsequently found new evidence for phosphine in the Venusian clouds with high statistical significance, employing entirely different data processing methods than the ones originally disputed by critics. According to researchers actively involved in this ongoing work, the original detection has now survived essentially every major scientific challenge thrown at it, and has gained meaningful independent support from old archival data originally gathered by an earlier American pioneer Venus mission decades ago. An intriguing new pattern has also emerged from continued observation. Phosphine signals appear measurably stronger as the Venusian atmosphere transitions from night into day, while weaker signals or non-detections occur as it transitions from day back into night, suggestive of the gas being actively destroyed by sunlight through a process called photolysis. Despite years of additional scrutiny and research, comprehensive scientific reviews continue to rule out every currently known non-biological explanation for the observed phosphine levels. The honest, current scientific position remains remarkably similar to where it stood back in 2020. Nobody has definitively proven life exists in the clouds of Venus, but nobody has yet found a satisfying, fully lifeless explanation for the gas either. This is precisely where the story stops being purely historical and becomes genuinely, actively unresolved right now, in the present moment. Real missions are currently being built specifically to chase this exact unanswered question. A private mission called Venus Life Finder, a partnership between an aerospace company and MIT researchers, is specifically targeting organic molecules within Venus's clouds, aiming toward a launch window in 2026. Alongside it, NASA has its own dedicated missions in active development specifically designed to study Venus's surface composition and geological history in far greater detail than any previous mission has achieved. None of these upcoming missions are explicitly framed as hunting for living organisms, but every single one of them is being built, at least in part, because of the exact same unresolved question that first emerged from a Soviet scientist staring at decades-old photographs and which later resurfaced through a single, stubborn, unexplained whisper of gas detected in an alien cloud layer. So where does that genuinely leave us? Standing here in the present day with one heavily disputed claim about moving shapes on a planet's surface, almost certainly explained away by noise, dust, and aggressive image sharpening, sitting right alongside a separate, still unresolved chemical mystery hovering in the clouds above that exact same hostile world. The honest scientific position refuses to offer the simple, satisfying answer that headlines always crave. It is not a confident yes, and it is not a confident no either. It is the far more difficult discipline of sitting patiently inside genuine uncertainty, stating clearly what is actually known, marking honestly what remains only suspected, and keeping the door open exactly as wide as the available evidence actually justifies. No wider and no narrower than that. We built sealed machines and dropped them through acid clouds onto ground hot enough to melt lead. We listened to alien wind through microphones designed by Soviet engineers decades ago. We pointed humanity's most sensitive telescopes at a bright point glowing in our evening sky and pulled out a single, nearly impossible whisper of a molecule buried deep within layers of noise. And after all of that effort, all of those instruments, all of those carefully argued scientific papers, we are still standing here today, looking up at the second brightest object in our night sky, genuinely unable to say with certainty whether anything down on that surface or floating somewhere within those poisonous clouds above it has ever been looking back. You get two images that are broadly fundamentally similar, but scattered throughout with a haze of meaningful difference. Data dropping out in places, pixel values drifting elsewhere, strange systematic artifacts appearing in specific spots. Almost all of that difference is noise generated by the transmission process itself, not genuine information about anything physically happening on the Venusian surface. When you combine all of these factors together, shifting ambient light, soil disturbed and blown by wind, and a thick, inconsistent layer of transmission noise differing between separate versions of supposedly identical images, you arrive at an uncomfortable but unavoidable conclusion. It becomes genuinely hazardous to read too much meaning into small, blurry shape changes from one frame to the next. That is exactly the precise spot where critics argue the entire Scorpion controversy actually lives. Not on the surface of Venus, but buried somewhere inside accumulated layers of ordinary transmission noise. Xanfamalides' claims did not stop at the Scorpion alone, and the way his other two objects behaved tells you a great deal about how seriously to weigh all three together. The object he called the black flap appeared in images taken within the first 13 minutes after landing, described as a vertically standing black shape wrapped partially around one of the lander's own measuring instruments, a cone-shaped tool used to test the mechanical properties of the soil. In the two images that followed shortly after, the black flap had simply vanished without any trace. Notice the timing here. Unlike the Scorpion, which he placed out on open, undisturbed ground, this object was clinging directly to the lander's own equipment and disappeared within the exact half-hour window when freshly disturbed dust was still actively settling and blowing away from the impact zone. The object he called the disk turned out to be the simplest and most damaging case of all for his broader theory. It was a regular, rounded shape, roughly a third of a meter across. He reported that it shifted position and changed form between separate frames, at one point appearing to fragment entirely before being replaced by a different, bright, angular shape he compared to folded chevrons. Here is the detail that quietly demolishes that specific claim, and it traces directly back to something mentioned earlier without much emphasis. Venera 13's two cameras each had a protective lens cap designed to automatically eject once the lander safely touched down. Engineers familiar with the spacecraft's actual design offered a far more mundane explanation for the supposedly moving disk. It was never one single object traveling across the ground at all. It was two separate, perfectly ordinary, completely inanimate, ejected lens caps, simply lying in two different physical locations on the soil, mistaken across separate frames for one continuous object that had somehow moved. A specialist who processes planetary imagery for NASA's Mars missions later pointed out something even more devastating to the theory. A strikingly similar crab-like shape also appeared in photographs taken by Venera 13's identical twin, which had landed nearly 1,000 kilometers away on a completely different part of the planet. If these were genuinely independent living organisms, occupying random positions on an entire planetary surface, the odds of two separate landers, touching down 1,000 kilometers apart, both happening to capture nearly identical objects sitting in strikingly similar relative positions, would be vanishingly small. It makes vastly more sense that both objects were simply standardized pieces of hardware, designed to behave identically because they were literally identical components built on an assembly line. And then there is the sentence that ultimately did the most damage to Xanfamalides' entire case, more than any external critic ever could. He had stated firmly in print that absolutely no retouching, no manual drawing, and no digital manipulation using image editing software had been applied to any of his analyzed pictures. But in describing his own actual methodology within that very same published paper, he openly admitted to filling in missing sections of damaged images using data borrowed from other frames, manually adjusting contrast and brightness levels, and perhaps, strangest of all, occasionally applying the basic blur and sharpen tools found in ordinary consumer computer painting software. Those are not trivial, harmless adjustments. Every single one of them actively alters an image, Sharpening, in particular, does something genuinely dangerous when applied to an already noisy picture. Pushed too aggressively, it begins inventing edges and outlines that were never actually present in the original data, pulling crisp, structured-looking shapes directly out of soft, ambiguous fog. So the very scientist insisting his images were completely untouched had, by his own explicit written admission, sharpened them, brightened them, and patched them together using fragments borrowed from entirely different frames. When a respected science communicator working for a major planetary research organization examined his published figures and methodology in detail, her conclusion was blunt and unambiguous. Given that much inherent variation in transmission noise across the original images, combined with that much aggressive sharpening and manual patching layered on top, she argued there was simply no scientific value left in micro-analyzing tiny shape changes to determine whether anything had genuinely moved, let alone whether it represented something biologically alive. In her assessment, there was nothing meaningfully present in the data at all. The story had already exploded across global headlines through a sensationalized wire service report proclaiming life had been spotted on Venus. The broader scientific reaction arrived swiftly and was overwhelmingly skeptical. A respected journal published formal editorial pushback alongside multiple critical commentary articles from other scientists. A major science outlet ran a thorough piece systematically refuting the specific claims point by point. And Kassan Famality himself, undeterred by any of this criticism, went on to publish a second follow-up article describing still more shapes he believed represented additional living organisms clustered around the same landing site, speculating about an entire ecosystem he believed the original images had captured. But that is genuinely not quite where this story actually ends, because years later, researchers went back and attempted to settle the underlying question using analytical tools that simply did not exist when Kassan Famality first made his original claims. For years, the entire debate had essentially been a standoff between competing human eyes. Kassan Famality looked at the frames and saw something structured and alive, while his critics looked at the exact same frames and saw nothing but noise and recognizable lander hardware. There was no neutral, objective referee capable of settling the disagreement mathematically. So, eventually, researchers brought in software specifically designed to not care about which side of the argument it confirmed. In a more recent published study, the Scorpion object, deliberately renamed simply as the target to strip away any emotionally loaded terminology, was subjected to 3 completely independent forms of analysis. The first involved detailed image processing, isolating, cropping, and magnifying the object alongside neighboring soil for direct structural comparison while running computational edge detection routines across both surfaces. The second involved machine learning, training a neural network to mathematically judge how visually similar the object's surface texture was compared to randomly sampled patches of the surrounding soil. The third involved fractal analysis, a mathematical method for measuring how complex and branching a given structure actually is, a technique previously applied to ambiguous surface features photographed on Mars. The results that came back were genuinely more nuanced than either side of the original argument probably wanted to hear. On one hand, the analyses did confirm that the object measurably stood out from its immediate surroundings. It appeared more sharply in focus than the surrounding soil, and fractal measurements found it was slightly more structurally complex and notably more visually uniform than randomly sampled patches of dirt nearby, with some evidence suggesting that measured complexity actually rose when the object first appeared and fell again as it later vanished. That finding is not nothing. It is enough to rule out at least one alternative explanation entirely, the simple possibility that someone had merely pasted a fabricated object directly onto the image, or that ordinary windblown debris had drifted randomly into the frame. The careful mathematical analysis argued convincingly against both of those simpler explanations, but on the other hand, those same analytical tools also found deep structural similarities between the object and the surrounding dirt itself. The branching, tube-like texture visible across the object's surface closely resembled the branching texture of the surrounding soil, and in certain places, the object's structure appeared genuinely continuous with the ground around it, flowing directly into the surrounding material, rather than existing as a clearly separate, distinct entity. The machine learning component found only the faintest statistical links between the object and its background, yet the deeper visual analysis told a more ambiguous story of an object seemingly built from the same fundamental material as the ground it rested on, partially merged with its surroundings, rather than sitting cleanly apart from them. So the study ultimately reached a carefully hedged, deliberately cautious conclusion. On the overall balance of probability, the analysis determined that the so-called scorpion is most likely entirely lifeless, and that its lifelike appearance most plausibly results from repeated, layered image processing applied to one particular patch of disturbed Venusian soil. Sharpen an already noisy patch of ground aggressively enough, repeatedly, and you can genuinely coax a shape out of the resulting fog that looks, to a hopeful human eye, remarkably like something possessing a head, a body, and limbs. And yet, this is precisely the detail that keeps the door from fully, permanently closing on the question. Even this more rigorous, technically sophisticated study explicitly refused to declare absolute certainty.